Welcome to the DIY Honda Garage channel. Today, we will address the DTC P0443, which indicates a malfunction in the EVAP Canister Purge valve circuit in the Honda CRV models from 2011 to 2016. This error often stems from issues within the evaporative emission control system, EVAP, which plays a crucial role in minimizing the vehicle's emissions by trapping fuel vapors from the fuel tank and subsequently venting them into the engine for combustion. The primary component in this system affected by the code P0443 is the EVAP Canister Purge valve, located in the engine compartment. When the engine control module, ECM, detects a fault in the circuit of this valve, the P0443 code is triggered, signaling that there could be an internal issue with the valve itself or in the connections leading to it. Understanding and resolving this issue is essential for ensuring vehicle compliance with emission regulations and optimal engine performance. The principal component related to DTC P0443 is the EVAP Canister Purge valve, which is strategically installed in the engine compartment. This valve plays a vital role in controlling the flow of fuel vapors from the EVAP canister to the intake manifold. During combustion, it ensures that the vapors are redirected to the engine rather than being released into the atmosphere, which is crucial for meeting environmental regulations. The valve operates under the direction of the engine control module, ECM, which activates it at specific times based on engine conditions. A malfunction in this valve can lead to poor engine performance and increased emissions, necessitating prompt diagnostic and repair action when the P0443 code appears. The focus of diagnostic procedures will revolve around assessing the circuitry, valve operations, and potential failures within the electrical components associated with this valve. DTC P0443 can be attributed to several potential issues within the EVAP system. One common cause is a malfunctioning EVAP canister purge valve that may either be stuck open or closed. If the valve is stuck open, it allows the fuel vapors to escape continuously, causing poor engine performance and emissions failure. Conversely, if it's stuck closed, the vapors cannot vent properly, which may bring about additional pressure issues within the fuel system. Additionally, damaged wiring or poor connections leading to the valve or the engine control module, ECM, can contribute to circuit malfunctions, leading to the P0443 code. Also, a faulty ECM itself, particularly if it has outdated software, can lead to improper functioning of the EVAP system. Addressing these possible causes through comprehensive testing is critical in resolving the P0443 error. When experiencing issues related to DTC P0443, vehicle operators may notice several symptoms. The most immediate sign is typically the illumination of the check engine light, indicating that the onboard diagnostics have identified a fault. This alert can arise due to various reasons, primarily linked to the malfunction in the EVAP system. Drivers may also experience poor engine performance, particularly during acceleration or idling, as the improper management of fuel vapors can lead to fuel delivery issues. An additional critical symptom is the potential failure in emissions testing. The malfunctioning valve may cause the vehicle to emit higher levels of pollutants, thus failing to satisfy regulatory standards. Recognizing these symptoms early can help mitigate more severe engine or environmental issues that could arise from prolonged neglect of the DTC P0443. The first step in troubleshooting DTC P0443 begins with verifying the issue. First, turn the ignition switch to the on position, labeled as II in Honda vehicles. This action powers up the vehicle's diagnostic systems, allowing you to observe any stored data. Next, Utilize the Honda Diagnostics System, HDS, to clear the DTC and reset the onboard computer's readings. After this step, start the engine and maintain the engine speed at 3,000 RPM without any load, while the vehicle is in the park or neutral position. Doing this until the radiator fan comes on allows the engine control module to reevaluate the system's condition under operational parameters. Following this process, recheck for any confirmed or pending DTCs using the HDS. If DTC P0443 reappears, the failure is confirmed, and you'll proceed to the next step. If not, intermittent issues may be present, and inspecting connections would be warranted. In the second troubleshooting step, you want to determine the specific failure type related to the EVAP Canister Purge valve. Start by turning the ignition switch to the lock position, which is 0, ensuring the vehicle is off for safety. It's vital then to allow the engine to cool below 140 degrees Fahrenheit, 60 degrees Celsius for safe component access. Next, disconnect the vacuum hose from the EVAP Canister Purge valve located in the engine compartment. Once this is done, connect a vacuum pump and gauge to the valve. This equipment allows you to measure the vacuum state within the valve when the engine operates. With the engine idling post-setup, check for any vacuum pressure. If vacuum is detected, this indicates the valve is stuck open. Conversely, if no vacuum is present, it means the valve might be stuck closed, leading you further based on the result of this test. Following the results from Step 2, the next troubleshooting step involves assessing the PC-SOL line and the EVAP Canister Purge valve. Turn the ignition switch to the lock position to ensure safety before proceeding. Disconnect the 2P connector from the EVAP Canister Purge valve to isolate it from the system temporarily. This is crucial for further checks, ensuring no power is supplied to the component during testing. The next action is to check for electrical continuity between designated test points. With the connector disconnected, utilize a multimeter to measure across test points, ensuring that the conditions reflect an IG lock state of 0. This process allows you to verify if there is continuity in the circuit. If present, it indicates a possible fault within the PC-SOL line. Conversely, if there's no continuity, the valve itself may require replacement, as it suggests a disconnection or failure within the EVAP Canister Purge valve itself. In this step, we will look for any shorted wires within the PC-SOL line that could be causing DTC P0443. Begin by jumping the short circuit switch SCS line using the Honda Diagnostics System HDS. This process prepares the system for a thorough continuity test. Subsequently, disconnect the PCM connector B, identified as 49P, which is necessary for isolating the main control unit to ensure accurate readings. With both the valve and PCM connectors disconnected, test for continuity between defined test points. The purpose of this is to verify the electrical pathway within the circuit under specific conditions, with IG lock set to 0. Should there be continuity in the circuit, then it confirms a short in the wire pathway, either between the PCM and the EVAP Canister Purge valve. If continuity does not exist, it indicates the circuit is intact, necessitating an update of the PCM software or substituting it with a known good unit for further diagnostics. This step involves checking for open wires in the IG1 PC-SOL, IG1 main, or IG1 ACG lines that could lead to the DTC P0443. Start by turning the ignition switch to the lock position and ensure safety before proceeding. Then, disconnect the 2P connector associated with the EVAP Canister Purge valve, which allows for direct voltage measurement. Next, turn the ignition switch to the on position, labeled as II, This action powers the circuits and allows you to measure the voltage at the designated test points. By using a multimeter, ensure that you take readings between test point 1 and test point 2. Adequate voltage indicates the circuit is functioning properly. If battery voltage is present, the wiring leading to the purge valve is intact, allowing you to proceed to the next troubleshooting step. If no voltage is detected, then it signals a break or open in the circuits between the purge valve and the fuse location, necessitating repairs. Continuing with the electric diagnostics. This step is crucial as it ensures the integrity of the PC-SOL wire. First and foremost, turn the ignition switch to the lock position to begin the safety checks. After this, utilize the HDS to jump the SCS line again, allowing for a streamlined continuity test. Next, once again, disconnect the PCM connector B49P to isolate the main control unit from the electrical network. Ensure to measure the continuity between the two defined test points as stated. Proper continuity between these points indicates that the wire is functioning correctly between the PCM and the EVAP Canister Purge valve. However, if this is not confirmed through your test results, it confirms issues within the wiring structure, necessitating repairs to any potential breaks or faulty wiring within the PC-SOL line before proceeding to additional steps. In this final troubleshooting step, we will assess the EVAP Canister Purge valve's internal resistance as an indicator of its operational status. Start by ensuring the ignition switch is in the lock position, again, for safety as you proceed with this measurement. Ensure that the 2P connector at the valve is still disconnected. This is essential for obtaining accurate readings. Use a multimeter to measure the resistance between the specified test points directly on the EVAP Canister Purge valve side. Ideally, at standard room temperature, you should observe a resistance reading between 23 to 26 ohms. This specification helps confirm that the valve itself remains mechanically sound and free from internal faults. If the resistance is within the range, you can update the PCM if it lacks the latest software, ensuring optimal performance. However, if the measurement falls outside this range, it indicates the valve has failed and should be replaced, followed by a verification of the repairs done. After conducting all necessary repairs, it is essential to verify that the work has resolved the DTC P0443 issue effectively. Start by turning the ignition switch to the lock position to set up for connectivity checks. Reconnect all previously disconnected connectors, ensuring they are secure and completely seated to prevent future issues. Once all connections are restored, turn the ignition switch back to the on position. Use the Honda Diagnostic System, HDS, to reset the Powertrain Control Module, PCM, ensuring that it has the latest updates and is functioning properly with the new components. Lastly, it is crucial to perform the idle learn procedure for the PCM, which allows it to relearn optimal engine parameters. Finally, monitor the OBD status for DTC P0443, checking for indications of passed, failed, executing, or out of condition. If the test indicates passed, the vehicle's EVAP system repair is confirmed complete. Preventive maintenance is key to ensuring the longevity and effectiveness of the EVAP system and preventing future occurrences of DTC P0443. Regularly inspecting the entire EVAP system for visible signs of wear, loose connections, or damage to hoses can help mitigate issues before they develop into a fault. Keeping connectors clean and free of debris is essential, as accumulated dirt can lead to poor electrical connections that may trigger diagnostic trouble codes. Careful monitoring of engine performance, particularly during times of fuel vapor circulation, can signal potential troubles early, providing an opportunity for timely interventions. Encouraging regular diagnostic checks and ensuring that the PCM is updated with the latest software will also enhance the reliability of the system. Adoption of these preventive measures is crucial to maintaining the vehicle's efficiency and compliance with emission standards. In conclusion, the DTC P0443 specifically points to a malfunction within the EVAP Canister Purge valve circuit, an essential component for managing fuel vapor emissions in the Honda CRV models from 2011 to 2016. Understanding the roles of these components and their locations aids in efficient diagnostics and repairs. It's critical to diagnose the system systematically, starting from confirming the error code through various checks and measurements to pinpoint the exact failure. Each step progresses logically to ascertain whether the issue lies with the purge valve, wiring, or the control module. Following the troubleshooting guidelines meticulously ensures that any repairs made restore the vehicle's performance and compliance with environmental standards, ultimately benefiting the vehicle's operation and the environment. Please like and subscribe to the channel. See you next time.